Welcome to the Sustainable Business Council Sustainability Shop tonight. We're excited to have you all here with us. We have a great presentation on 10 ways to reduce your energy costs. Before we do that, I'd like to thank a few people who help us put this on. First off, we'd like to thank MCAT for coming to film these presentations for us on a regular basis. It's very helpful because then it gets out in the community as well as the group who manages to make it out. Tonight we are at the Loft, and we want to thank them for the usage of their building. The Bridge has provided us with some wonderful pizzas. Those of you in the audience, if you haven't tried it yet, go do so. And Big Sky Brewing has also provided the beer for tonight. We also have some sponsors for this event who help us with all the financial arrangements on the event. That includes Axiom IT Solutions, Livesey, All Freight Systems, Missoula Independent, Cherry Creek Radio, MacArthur Means and Wells Architects, and Family Dental Group. We encourage you to check those businesses out. You can go find more out about them on our website, www.sustainablebusinesscouncil.org. Tonight, we have Russ Helm and Andy Lehman, which I probably just said wrong, from Energetics. They are going to talk about 10 ways to reduce your energy costs. And between the two of them, they have years and years and years of experience in green construction and energy efficient design. I'm going to leave it at that and let them tell you a little bit more. They're going to speed through the 10 ways. This is kind of like the David Letterman's top 10 list we're going to get here tonight. And then we're going to open the floor to questions. We should have 30 to 40 minutes of questions, so you'll have plenty of time to get whatever you are dying to know about your own facilities answered from our wonderful experts tonight. So please help me welcome Russ and Andy.
Thank you. Thanks for coming out. We're excited to be here and excited to share the experience that we have with energy efficiency. And we'd like to know a little bit about you guys. So maybe get a little show of hands of what kind of people we have in the audience tonight. How many business owners do we have here tonight? And how about employees of businesses that are here sort of representing or learning for the businesses that they work for? And then how about homeowners? All right, great. We're excited to know who's here, and we can kind of help to kind of cater some of the information we're sharing towards you all to hopefully answer your questions and teach what you guys want to learn. So I'm Russ, and I'm the owner of Energetics, and I've been doing energy efficiency work for about 5 years. I've had Energetics, and before that I was in the construction industry building houses, and I moved into this world just because of my passion for energy conservation and green building stuff, and to be able to educate people and try to make as big of a difference as I can. And this is Andy. I'll let him introduce himself.
Andy Lehman is my name, and I studied architecture in Australia about 25 years ago, and then had my own design build firm for a long time, and then I've worked for contractors and architects and different things, and then started working for Russ a couple of years ago, and I've always been interested in in energy efficiency and sustainability, but I've learned more in these last 2 years through this job, where we're actually going out and testing buildings, doing energy audits, and actually seeing, the end result of the things that I have been doing for 20 years, and so I've developed a very different understanding of energy efficiency through this job, and hopefully we can pass some of that on to you. So 10 ways to save energy or to reduce energy costs. The sort of primary focus is on energy, but the subtitle, a systems approach, kind of points to what we've the approach we try to take with everything we do is to look at a building as a complete system, so that we're looking at. Let me go to this next slide. So it's not just energy. There's health and safety and comfort, and durability and responsibility, which could include things like financial responsibility, environmental responsibility, social responsibility, that kind of stuff. But the point being that when we're looking, say, doing an energy audit, we're looking at a lot more than just energy efficiency, because it's quite easy to create other problems. If all we're looking at is energy efficiency, we could quite easily create a health and safety problem in a building. For example, if we went into a home and did a whole bunch of air sealing in a home, made it really tight, without first testing the furnace and water heater to see what kind of condition they're in, we could create a situation where the furnace and the water heater backdraft, and you get flue gases coming back into the air that you breathe inside the home. And there's a whole lot of examples I could give where you could create a health or safety or a durability issue if all you're looking at is energy. So we try to look at the whole system, and it's more like a holistic approach. So getting into our top 10 list, and we'll try to kind of work through these.
We'll touch on more of the systems approach stuff as we get into this, but we're going to kind of go through a number of these different top 10s, but kind of keeping that in mind, the overall systems approach and how the different parts within the building interact with one another. So one thing that isn't really affected necessarily by systems is keeping it small. Only using as much space as we need, whether it's a commercial space for a business or a residence. These pictures paint a pretty nice picture of which one's going to use more or less energy, and so trying to maximize whatever space we are using, so that we can use as little as possible.
And simple is fairly key too. The simpler the structure is, the easier and more cost effectively it can be made really energy efficient. And when we get to the end here, if anyone wants it, I've made a handout that has sort of this list of 10, just the summarized basically. So number 2, measure it. It's sort of one of the rules of business. If you want to manage it, you have to measure it. So this applies to energy as well. If you don't measure it, it's very difficult to manage it. And so some of the things you can do to measure energy, very simple things like these little plug-in kilowatt meters. If you want to know how much energy your fridge is using, you can put one of these on it, and it'll tell you. Or you can get slightly more sophisticated. This is a shot of a computer screen of this TED, which stands for the Energy Detective, and it's kind of a whole house energy monitoring system that runs off the meters for the house. Which if you want to see one in action, if you ever get a chance to go to the Flat, if you've ever heard of that project, it's kind of a demonstration project they're doing at the university, and they have one of these systems in place, and you can actually see, when they turn the stove on, you can see the spike in the energy use, and it's pretty interesting. But it's limited in effectiveness by the number of meters that are tied to it, and so the next point is about measuring it is sub-metering. And Russ, you might talk about that, what you did in your duplex.
Yeah, so on a simple level, here on the right side you see a gas sub-meter. I built a house a couple years ago, or a duplex a couple years ago, and I wanted to monitor energy use in it. It was a very well insulated, super energy efficient building, and I wanted to see where the energy was being used. So I had sub-meters on the gas side and on the electric side to be able to see exactly how much each A and B unit is being used. And so I could see how much hot water they're using, what's being used for heat. I didn't get into monitoring the different circuits on the electricity side. I'm not seeing exactly what they're using for the refrigerator and how much they're using for their computers and stuff like, and different plug loads, which is anything that plugs into the wall. That can be done on a simple level, that the TED or the energy detective, like Andy was mentioning, is a good way to do it. For more complex systems or looking into bigger buildings, there's other systems that work really well. We have a colleague here tonight, Ryan Alter, that has monitored some of the Missoula Housing Authority projects where they're actually seeing a bunch of different circuits in the building for the central electricity use, not in each apartment, but all the central corridors, and how much the solar panels are producing, and they're looking at exactly where all their energy is going for all these different circuits. So now and we just had a meeting with them the other day, and they were.
I'm going to bring that up really quickly.
Yeah, it's a good idea.
I have it on my computer. So I can really...
For businesses, some of these things we're talking about is great for really small businesses, for larger businesses, larger commercial buildings. Looking at something a little bit more complex to manage specific areas, and you'll see in a second, Ryan's going to bring this up, where we're looking, there's about, 10 circuits that they're looking at. Yep. This is the Garden District building. I don't know if you guys are familiar with that. It's over on Catlin Street. It was just finished last spring. And they've got a big solar array up. And that was one thing they wanted to see, was how much energy it's producing. But on the flip side, they wanted to see how much they're using. So we can see here, there's 7 or 8 different circuits that they're monitoring, looking at in the past hour, the past day, and then the total energy use since they started last April. Their elevator has used 1,568 kilowatt hours, miscellaneous draws. The first floor heaters, they had some electric heaters just like in the hallways, just for spot heating. They have that monitored. Basement heaters, that one's got a big draw. You can see that there's some issues with that one. You can see just the basement heaters are using as much as the elevator is. And we had a meeting over there the other day, and they were asking us, well, what can we do about this and for future buildings? And I said, well, you super insulate the basement, you don't even need these. So what the monitoring allows us to do is to learn from our mistakes, for one, and to plan for future design. Looking at, okay, well, we're going to move into a new building, which we're going to be doing in about 6 months. And I've got some monitoring data from my duplex, which is a residence, but I can look at that and say, okay, I'm going to learn from the monitoring that we did and use it to educate ourselves, in this case, to be able to make decisions for the future.
It also allows, like, if there was a problem, like if these basement heaters were not operating correctly and were left on like the whole time or something, all through the summer, you'd see it spike on this chart and so on. And when the solar panels are producing, you'll see this arrow right now is showing there's power coming from the grid to the building. When the solar panels are producing, you'll see arrows coming down. And is this available to anyone to log in and look at? So anyone who's interested, talk to Ryan afterwards, and he can give you the login information, and you can go and log in and just see what's happening in this building at any time.
Yeah, and they're likely going to be adding some additional circuits to it. You were talking to them just a couple days ago about adding some of the residences and starting to monitor the heating systems and monitor some of the circuits within the apartments to kind of compare how different occupants are using the systems and how the different apartments are performing from an energy efficiency standpoint.
And that kind of brings us to our next point, if you could bring the PowerPoint back up, which is about occupant behavior. And Russ's duplex is a good example. He's got 2 apartments with the exact same floor layout. They're both super insulated, same systems. One uses twice as much energy as the other one because of the way that they both have 2 people living in them. And one couple is careful with energy and the other couple isn't, and they use twice as much energy. So
I would say, this is absolutely the number one cheapest thing anyone can do. I mean, I have
not just turn lights off, but modify your behavior.
Yeah. I mean, just from how long you take a shower, or how long you leave the water running, or how long,
or if you just ride your bike to work, or there's 1,000 things you can do that are just choices you can make that you don't have to spend any money on or change anything to do with the building. If you just change yourself, you can. I mean, any one of us here, I bet if we wanted to, we could cut our energy use in half tomorrow if we really tried.
Yeah, I last year about this, it was actually a little earlier, about September of 2009, I approached my wife and I said, what do you think about us not using a dryer anymore? So what do you think, And I said, I'm ready to get rid of it, like take it out of the house. And she's like, well, let's see how this winter goes before I make that commitment. And I was okay with that. And we pretty much, we still have our dryer, but we've used it, I'd say less than 10 times in a year. And I've watched our electricity bill go down significantly. And it blows me away because I have my wife, she's home full time with my 2 boys. And our energy bills are close to as low as some of my duplex occupants, and that building is crazy super insulated compared to my house. And it just shows me that the occupant decisions on how we choose to live really influences the overall energy use. We don't leave lights on. Right. Sorry, go ahead.
I was just going to say one point on the dryer though. If you plan on drying your clothes inside, really got to be careful about humidity levels inside the house. Do you have a specific? So Russ has a heat recovery ventilation system in his house and has an exhaust point from where the clothes are dried. So he's taken care of it, but you do want to watch out for that.
Yeah, I don't want to.
That's an example of where you could create a problem by when you're trying to solve an energy problem. You could create a mold problem, for example.
Yeah. That's where the whole systems approach comes in, and obviously I have that knowledge to know what the effect of hanging clothes in my house in the winter is going to do to the building. So I made sure that I dealt with that by having ventilation in there to address it. So,
this is pretty obvious, turn things off, but standby loads, we've all heard it, but how many of us have actually taken the trouble to take all our stereo equipment, put it on a power strip and turn the whole lot off every time we're not using it? Or our computer, in our office, we've done it now where every one of our computers, printers, all of that stuff is on one power strip, and when we're done in the evening, we turn the power strips off. So all of that stuff, and they can use a crazy amount of power, and all night long when no one's there. So power strips are great. Occupancy sensors, if you go to these bathrooms down here, you'll see them in action. You walk in, the light comes on, you walk out, the light goes off. You can't accidentally leave the light on in that bathroom. Task lighting, if you come to our office, we get people making fun of us all the time because we're sitting there in the dark, with just lights on what we need, instead of having the whole place lit up.
And we help each other with occupant behavior.
Right, yeah.
I'll be in early in the morning, and for whatever reason the lights are on, and Andy will walk in and he'll say, "Do you need these lights on?" and vice versa. And it's more just awareness, being conscious of our choice.
Exactly.
It's just like, am I consciously deciding to leave them on or off or whatever?
Every day when I leave for work, I stop and think, do I need to drive my car today? And 95% of the time the answer is no. So I ride my bike. And I have a little trailer that goes on the back of my bike. If I need to pick up 2 bags of groceries, I don't need to drive just for 2 bags of groceries. I take my little trailer and I can carry quite a bit on that. So there's just choices. So here's another one. Thermostat. Rethink the dress code. Office buildings that are air conditioned down to 65 degrees in the summertime, and everyone's wearing coats and ties and freezing cold. It's ridiculous. Wear a comfortable shirt and turn the thermostat up in the summer, or turn it down in the winter and put on a sweater.
And something related to that, but that we'll hit on a little bit later in another point, is testing and balancing the mechanical system so that you actually have the appropriate airflow or heat or cooling to the specific areas in the building. Mm-hmm. Oftentimes in commercial spaces we see it a lot where people are either have a space heater under their desk, or they have their jacket on because they're freezing, or they're really hot or window open. And so, commissioning and testing the building system, the mechanical systems to make sure it's operating correctly is a big one.
Yeah. And then there's, a lot of low-tech solutions like insulated blinds or ceiling fans that can make a huge difference to comfort. You know, blinds can make a big difference summer and winter. You do need to be a little careful with insulating blinds. If you don't have very good windows, you can end up getting a lot of condensation on windows if you use insulating blinds, which is another argument for really good windows. We'll come to that, come back to that anyway. So getting into this, all of that above was sort of more occupant behavior and choices. Now we're getting into the sort of the specifics of buildings themselves, and the best way to approach improving the energy efficiency of buildings, of existing buildings, is starting with an energy audit. And you know, it needs to be a comprehensive kind of an energy audit that particularly includes combustion appliance safety. You know, it touches on what I was mentioning before, where you can create serious problems in buildings if you're not looking at the whole building as a system and doing a comprehensive energy audit. But what an energy audit does for you is what you end up with is a prioritized list of the things that you can do to the building. And if there's any when we do them, if there's any health and safety issues, then they're first in the list. And then the energy improvements are prioritized based on what's going to give the best bang for the buck, basically. And there's a number of companies in town that do them. We're one, and there's another one represented over here, the Energy Doctor, I think so.
Dr. Energy Saver.
Dr. Energy Saver. Yep. But this is highly recommended. In fact, we're at the point now. We have two companies. So Energetics is the consulting side, and then Montana Energy Services is the contracting side. And we do insulation and heating systems and pretty much any kind of energy efficiency improvement contracting. But we've got to the point with Montana Energy Services where we pretty much won't do anything on a building unless an energy audit has been done first. A proper energy audit, not the free energy audits that you can get from various places don't go far enough as far as we're concerned. There's not enough emphasis put on the safety and health issues, and also, I mean, for one thing, they don't use an infrared camera, so you can do what's called a blower door test to find leaks in a building or find out how leaky a building is. But unless you're using an infrared camera and a smoke pencil and going around and spending the time to find where the leaks are, the blower door test is only marginally useful.
So you just to explain this image in the middle, this thermal image. Yeah. The infrared camera shows temperature difference. And so on this scale on the right side shows, warm to cold from the top to bottom. This is in a bedroom. That's an interior wall that connects to the attic. There's a drywall on the ceiling, drywall on the wall, and that big dark blue line or purple line is really cold air coming down from the attic.
Behind the sheetrock.
Behind the sheetrock, between the sheetrock and the framing, down the wall and into the building. So that's just one of the things that's looked at, and that's happening during a blower door test. Mm-hmm. The blower door test, if you're not aware, what it does is it creates a negative pressure, like a vacuum in the house with a big fan set up in the doorway, sucks air out of the house. And as that air goes out the house, it comes in through leaks in the building envelope or in the shell of the building. And then you walk around with the infrared camera to see, well, where is the air coming in and how do we deal with it?
And then, so that's a big part of the energy audit. But the other really big part is the testing the combustion appliances and making sure that things aren't backdrafting or spilling carbon monoxide or other poisonous gases into the building and all that kind of stuff. So it's a proper energy audit. A comprehensive energy audit is a very thorough home inspection, basically, with a focus on all those things that we looked at before: energy, comfort, health, safety, durability, all that stuff. All this stuff. I knew I put this slide in for a reason. Yeah. So it brings us back to this: is the energy audit needs to look at all of that stuff.
And that's kind of why, when he mentioned people call us to give a bid on this or that for insulation or air sealing work or anything related to some of the improvement side, and it's like we don't know what we're starting with. So we can't come in and make a recommendation for what we're going to do. And so the audit allows us to be informed about the decisions that we recommend and what we're saying we want to do. And so as a business owner or a customer, the audit allows you to see, okay, where in my building is it most important to focus my efforts and energy and money, really? How can I, first of all, make sure my building's safe and durable and healthy for the occupants. Then we start looking at, okay, what can we do to make it more energy efficient?
Which brings us to how to make a building energy efficient, and it comes down to basically this. Build it tight and then ventilate it right. Build tight, vent right. And then you could also add a little subtext and use efficient equipment and controls. So a little more about this. So building tight. Building tight requires excellent insulation and air sealing, and that's the air sealing is one of the parts that is often overlooked. You can put as much insulation in an attic as you want, but if you haven't air sealed between the house and the attic, heat's going to leak out through, because insulation doesn't stop air movement. It slows heat flow, but it doesn't stop air movement. And so you need to have a continuous air barrier and a continuous insulation layer around the entire conditioned space of the building. Insulation and air sealing, and then windows are really key, because they are part of a whole lot of different systems of the building. They're part of obtaining views and letting natural light in. They're part of the waterproofing of the exterior of the building. They're part of the insulation layer. They're part of the air sealing layer. Windows are really, really key. And so spending the money on really good windows is well worth it. And so that's sort of the fundamentals of building tight. And then venting right, you want to talk about?
Yeah, so venting right looks at a number of different things, making sure that different building assemblies, such as the attic, is vented correctly. A tight building, or any building, really needs to have proper ventilation in any of these unconditioned spaces. We like to see actually venting up the wall too, to allow air to freely move between the insulation layer on the outside and in the cladding or the siding, and then up into the attic. This venting allows, make sure that there's not excessive heat buildup in the summer and any moisture buildup in the winter. The next thing with venting is making sure that there's sealed combustion systems in the building. And what that means is high efficiency equipment today has a combustion air pipe coming right into the furnace and flue gases going directly out. So it's a sealed system. There's a fan that forces the combustion gases out to the outside, and it's sealed in a plastic pipe. Whereas old furnaces, they counted on warm buoyant air rising up through a big metal flue.
And not just old ones.
There's
builders are still installing these things like mad, although there's a lot of people like us who think they should be outlawed because they're a real safety issue.
So that's called an atmospherically vented appliance. Water heaters, furnaces are typically, that's the main ones. Fireplaces can also be atmospherically vented. And like I said, they're just counting on the flue gases being warmer than the surrounding air, so they're going to go up through this chimney and out through to the outside. The problem is as buildings get tighter, there's not sufficient makeup air in the building for that flue gas to go up and out. So let's say I turn on an exhaust fan, or I turn on a dryer or a range hood, and now all of a sudden I'm pulling flue gases, which typically have carbon monoxide in them, back into the house. And obviously that's going to create health and safety problems for the occupants.
And even if you're not doing that, if you don't have sealed combustion appliances, you have to put a great big hole in the side of the building. By code, you have to have, if you have a atmospherically vented water heater and furnace, you have to have an 8-inch hole in the side of your building.
Because it pulls its combustion air from the space that it's within. Whereas a sealed combustion system, there's 2 pipes right into the sealed cabinet of the furnace or the water heater. And the sealed combustion appliances are much more efficient, typically they're over 90% efficient. So
up to 98%.
Yeah, it's amazing, that they can't get much further on the gas appliances on efficiency. They're approaching 100%. The last thing we're looking at is ventilation for the occupants. And this is basically just controlling the fresh air inside the house, making sure that there's good indoor air quality for the people to breathe and to avoid any potential condensation problems and buildup of pollutants. A heat recovery system actually recovers a large portion of the heat energy from the outgoing airstream. It takes stale air from the building through a duct system or tied into a forced air duct system, takes it, goes through a machine that has a heat recovery core in it. It's just like a little radiator, basically. It's an air-to-air heat exchanger is what it's called. As the air goes out, it recovers heat energy from it. Fresh air is coming in at the same time, and that energy path is transferred. So you're getting, up to 95% transfer of the outgoing air. The heat from that is transferred to an incoming airstream. So on my house that I live in is relatively airtight, and I have a heat recovery ventilation system that runs 24/7. It just brings in fresh air. And I don't pay that much for it because it's recovering mine recovers 92% of the heat going out. And it manages the moisture within the building. It condenses out humidity to make sure that I don't get too high of a humidity in the building. And it allows us to breathe fresh air.
And then the last part of that was using efficient equipment. I mean, you could make a really tight and well ventilated building, but if you really want to make it energy efficient, you want these 98% efficient furnaces and water heaters, or ground source or air source heat pumps can be very efficient. They can also tend to be very expensive. But and then this here, this is what's called an energy recovery ventilation system, which is similar to a heat recovery system, but more efficient. And it's a lengthy explanation as to why. But up to 95% of the heat that's being exchanged can be recovered.
And aside from installing new systems in your buildings, looking at what you currently have, commissioning it means having it tested for performance, making sure it's working properly. You would not believe the number of buildings. I mean, every single one. Every one we go into. Even the ones that we install new stuff, and we come back, we look at it, before we leave, we're testing it. We have to test it to make sure it's working properly. I would say, almost every building we go into, we see an issue with how the current mechanical systems are operating. Either they're not operating efficiently from a combustion standpoint, or the delivery system on whether it's the forced air or hydronic heating or something is not operating correctly.
For example, in a commercial building I read about, they did a whole big energy audit, and they discovered that when they installed the heating system, they had put two fans facing each other. And so they were both running full bore, just blowing air at each other. And so nothing was going to the building, And by turning one fan around, they saved, hundreds of thousands of dollars a year.
Oh, and there's a commercial building that we did a extensive audit on, where a number of their mechanical systems were pulling their return air, which is supposed to be a fully ducted system, back from like that. That's a return air grill right there. That pulls heated air from here, goes back to the heating system and filters it and reheats it. They're pulling their return air from the attic space or from the crawl space. Well, how clean is that air? And how energy efficient is it? Crawl space, it's just like, this building had major indoor air quality problems. And part of it was the mechanical systems, and part of it was a whole bunch of other stuff. But looking at those things is really important.
And just regular maintenance, just making sure filters are clean and things are operating correctly.
Did I skip one?
Yeah, you did.
There we go.
So this is a bit of an esoteric thing, but we'll just touch on it. Is that especially if you're in the manufacturing, or if you have computer servers or machinery that makes a lot of heat, look for opportunities to recapture the waste heat and use it in productive ways. And then renewable energy, there's a lot of talk and hype about renewable energy, and it's great stuff, but our approach is always reduce the amount of energy you need as much as possible first, and then look at renewable energy. Solar, wind, hydro, all those things. But if we're never going to be able to replace fossil fuels entirely with renewable energies. It's just not going to happen. So we have to conserve energy as much as possible, and then look at how we replace the remaining energy demand with renewable energy systems. So that's our top 10.
Yeah.
Like I said, there's handouts here that you're welcome to grab later that kind of have those summarized. There's also an article here from the Building Science Corporation, which outlines a lot of those problems that can be created. The guy who wrote this was working up in Canada 30 years ago during the last energy crisis, and they started going crazy with insulating and air sealing buildings, and they created all sorts of problems with combustion appliances backdrafting, mold in attics, all sorts of stuff. And he basically outlines, what needs to be done and how we should be learning from those mistakes that were made 30 years ago, but also saying that we're in the process in the States right now of repeating that whole big debacle that happened in Canada 30 years ago.
We get it weekly. We
Yeah.
get the request weekly. Please come. We want insulation added, or we want to seal up our building, and we just, that's why we say we have to do an audit first to know.
Yeah, and we give all our customers a copy of this and say, go read this, and then call us if you want an energy audit, basically.
All right, we have our top 10 down. Now you get to ask your own personalized questions about energy use. Who would like to ask our experts here a question?
So if I get my efficient condensing boiler installed by a reputable vendor and inspected by them once a year under a maintenance contract, is that sufficient, or do I need some other test to make sure it's really set up and working right?
On the deliveries, if the boiler itself is properly working, if it's tested for efficiency, you said you have a condensing boiler, high efficiency?
I meant furnace.
Forced air?
Yes.
Okay. Two different delivery systems of heat. So looking at the efficiency of the boiler or the forced air furnace, making sure, testing it, you can actually measure how efficiently it's actually working. You measure the flue gases to see what the content of the flue gases is. I don't know if they do that or not. Testing the gas pressures and stuff like that. But then looking at the actual distribution system, the duct system, to see how well that is actually performing. If there's too much resistance in it, if a duct system's not designed well, you're going to end up with a lot of resistance to airflow, which means the furnace has to work harder to deliver the air that it's calling for. You can imagine driving down a road and coming up to an S-curve in your car, you can kind of weave through it pretty easily, or coming up to a hard 90-degree turn. How much harder is that for you to make that? And it's the same thing with airflow. If it's easy for the air to flow, it's going to be less resistive to the fan, the blower on the fan, and the furnace isn't going to have to work as hard.
And the other big thing is if there's a lot of leakage in the ductwork, it's estimated that in some buildings 30 to 50% of the heat that's being made by the furnace is being blown straight outside, not getting into the building at all because the ductwork's leaky and it might be running through an unconditioned attic, or it might be in the floor space that has leaky rim joists or something, and 30 to 50% of that heat can just be completely wasted if you have unsealed ductwork. So there's quite a few things that need to be looked at.
Yeah, I mean, if you really, there's a couple ways to do it. Is to test for duct leakage, or if the duct system is visibly difficult to seal, then reduct it and make sure that it's done properly. If there's a couple different ways to approach duct leakage. But does that answer your question?
Yeah.
Okay.
Could you go back to the dryer question? I have, for several years now, used a dryer, and I lay on all my friends and children about not using dryers. But I never thought about this moisture in the air thing. In fact, I thought it was kind of nice to have a little bit of moisture in the air. How do you know if you've got a problem, other than having you come out and go?
Well, a start is how much condensation you get on your windows. If you're getting a lot of condensation on your windows, chances are you're probably getting condensation other places as well.
And that's what worries us. I mean, condensation on the windows is not a major issue because we can see it. Or it's not as big of an issue as it could be in other areas. If you have an uncontrolled air leak or an unforeseen air leak that you don't know where that air is going, you could have that moisture problem in a enclosed cavity or somewhere where you don't spend time.
Or in the attic.
Or in the attic. And we've dealt with this, moldy attics. Attics with mold in them, created by a number of issues, but one of them is uncontrolled air leakage. That air that carries the moisture in it goes into the attic and reaches the dew point temperature, similar to what happens on the windows. Same thing happens in the attic.
Probably things like showers and bathtubs and things put water into the air,
And-
it's the same problem.
And those need to be vented to the outdoors.
And kitchen stoves, very important, especially gas stoves. Because when you're cooking, obviously you're creating moisture by cooking, but what most people either forget or don't realize is that just by burning gas, the byproducts of burning gas are carbon dioxide and water. And so just a gas stove by itself produces a whole lot of humidity.
Let me clarify the complete combustion
Right.
of gas. If
Right.
it's incomplete, if it's not 100% efficient, there's carbon monoxide in that air.
Right.
So if you have an old oven or cooktop that's not burning efficiently, you could be spilling carbon monoxide into the building. And so the range hood to vent that out is extremely important for gas burning.
Yeah, I just tested a house 2 days ago where the gas stove, when it wasn't running, was leaking gas into the building, and when it was running, it was leaking carbon monoxide into the building, and the range hood was just recirculating. You know, they had a range hood, but it wasn't going outside. It was just putting all of that back into the building, and that building was nasty.
This is rather scary stuff, as you sit here telling us about it. I think about my old house down here.
Chances are his old house is leaky, though.
Yeah. So if here's to make possibly easier concerns. If a building is leaky enough, the moisture and the things that are built up within it are leaking out everywhere. And so if you have leakage everywhere, the chances of there being an issue are less than if you try to seal it up a little bit. And that's why, why we won't seal up buildings more. I looked at a pretty leaky building today. They wanted minimal air sealing work done, and I said, I can't do it.
Not that we can't do it, we just can't do it until
Yeah.
the other things are taken care of. Because if you want energy efficiency, you have to make the building as tight as possible. But if you make a building as tight as possible, then you have to really pay, or before you make a building as tight as possible, you really have to pay attention to venting it right. Remember, build tight, vent right. It probably should be the other way around. Vent right and then make it tight. So venting right being the indoor air quality, so heat recovery, ventilation, the combustion appliances, so sealed combustion, furnace and water heater, or gas fireplaces, that kind of stuff. And then making sure that unconditioned spaces, attics, crawl spaces, if they're not heated, are vented properly. Otherwise, moisture builds up in those unconditioned spaces.
Some of the payback periods make these decisions really tough. For instance, we have a 1,200 square foot house, a lot of single pane windows, but the double pane windows can be $400 easily. So 6 or 7 of those. Our heating bills maybe $150 a month. We have 4 or 5 big winter months. When you start doing the math, it makes it difficult. Do you invest $3,000 to maybe save that $100, $150 per winter? Do you all have magic numbers as far as payback periods? But I also realize there's the aesthetics, there's the air quality, and you're living in this house too.
Right.
So you got to balance all that out.
And that's why we look at this. Again, we come back to it a lot.
Well, there's great tax credits right now.
There is.
So
Yeah.
Yeah.
That there are some incentives that really help.
But you're right, though. If you just look at the numbers, a lot of it doesn't pencil out. But how do you put a value on health and safety, or how do you put a value on comfort? One of the big things with windows, when you go to a triple glazed or equivalent kind of a window that is something like an R5 performance versus, a single pane window is basically R0. And even a double pane window might be R2 or 3. The surface temperature of that glass might, if it was double pane, it might be, let's say, well, you did it on your duplex where
I shot surface temperatures in my house, which has double pane windows, R value of 3, which R value stands for resistance to heat transfer. The higher the number, the better the resistance. Mine was a 3. My duplex was about 5.5, so almost double. And I shot the surface temperatures with a fancy instrument that we have, and it, I think the outdoor temperature was like 16 degrees, and the inside surface temperature on my double pane windows was like 36, 38, something like that. Went over to my duplex, same outdoor conditions, shot it, and it was in the mid 50s. So the 20 degree surface temperature increase. What happens is the heat from our bodies goes to the cold, it radiates to the cold surface temperatures. So the colder the surface temperature, the colder we feel, because more heat's being drawn away from our body. So the warmer the surface temperature, the more well insulated it is, the more comfortable we are. And every time I go into my duplex to hang out with my tenants, I'm always jealous of how comfortable it is in there, because it's so incredibly well insulated that it's just incredibly comfortable. So payback is really something we don't push a lot right now. In our opinion, energy prices are not high enough.
Right.
And that'll change,
So
Yeah.
Well, this kind of leads into my question about, and this might help you as well. And you mentioned this before, talking about blinds or window quilts or things like that you could put on a window that might be a lot less expensive than a new window. I have them in my house and I use them, and I do notice a lot of condensation. I don't really know what that means exactly.
So it's a catch-22. If you have really good windows, so in Russ's duplex with the triple pane windows R5, you can put a blind on those and you won't get condensation. So you can improve the performance again and not have a problem, whereas you take an old window and try to improve the performance and you create a condensation problem.
what happens is the blind is reducing the amount of heat from the house that's going through that window. But getting to the window, yeah. But what it's not doing is it's not stopping air from the building getting to the window, because it's not a completely sealed blind. And in that air contains water vapor. And when the suspended water vapor reaches the dew point, which is when it hits your window, and the dew point is relative to how much humidity is in the air. The drier the air, the colder that dew point can get before you see condensation. I don't know if you've ever spent time in the humid South or the Midwest in the summer, but you go around and there's dew all over the grass, like, you know, every night. But here in Montana, do we barely ever see dew? No, because our relative humidity is really low. There, the relative humidity is really high, so that water vapor condenses. And so the same thing happens on your window. You get water vapor, reaches the dew point, goes around the blinds. You know, like my blinds in my house, I have cellular blinds, and it really helps with comfort, but the air can still go around them, so the water vapor and air get to.
What's the downside of that?
The condensation on the windows?
If depending on the window, it can eventually create mold if you have wood windows or wood sills, and it could cause the window to fail.
It can also leak down in these little gaps here. One of my clients told me that they squeegee their windows every morning to get there's that much moisture on them. And if they didn't do that, all of that moisture is going to get into that wall, and you know it's going to create mold in that wall, inside the wall cavity.
So you can solve the problem. You just have to have sealed blinds, which I don't have a specific answer. One builder fanatic friend of mine who's really in energy conservation, he'd put up chunks of foil-faced foam board over his windows at night, and they sealed.
But they have to be totally sealed around them, you know.
Right.
There's basically there's two other ways you can deal with the condensation on the windows. One is to improve the window or reduce the humidity inside the building.
Seems like there's another option, is a shutter on the outside. It doesn't need to be sealed well.
Right. No, you're absolutely right. But I've yet to see one that anyone would use for very long. Most of the ones I've seen, and you know, in the 70s, people did all sorts of experiments with these things and created these things that you have to go outside and put them up and see, do.
Yeah.
They quit using them after one winter because they got tired of going outside to put the shutters up.
I agree. It would be great. And one of our employees is, he's talked about wanting to build some shutters that slide into the wall, and he just presses a button, and
Yeah.
Like
one of those roll down screens.
Sure, yeah, absolutely.
There's sort of a trade-off because you say, okay, well, how much is that going to cost me, or how much is it going to cost me to do a triple pane window? And so.
So this comes back to the point. The first point was the KISS one. Keep it small and simple. If you start with a very small and simple building, hopefully you can afford then to put in really good windows and really good insulation, really good air sealing. It's when when it gets bigger and more complicated, the costs grow exponentially to try to make it energy efficient. Yes.
So we've fixed this now, but when the house that we are in now, they vented the bathroom into the attic.
That's common.
Which
We
is
see that
and
all the time.
I understood it was common. We've obviously fixed that. It goes to the outside now. Can you give us a list of 5 or 10 things that in older houses it's really common to see that are either not good for the health or not good for the energy picture of the house? I mean, like that. I mean, there's some.
Atmospherically vented furnaces and water heaters are in almost every old house, and many of the ones that we've tested have been backdrafting poisonous gases into the air that you breathe inside the house.
Is there a way to convert those without putting in a whole new,
Nope.
So glad I get.
Yeah. The venting of range hoods and bath fans into attics, very common and very bad idea. What other ones would you say?
I would say crawl space, properly sealed
Oh.
crawl space vapor barriers.
Yeah, never see properly sealed
Because a crawl space, a crawl space inside the building, shell, but oftentimes in old houses we see exposed dirt, and people think of, a crawl space. Well, it's kind of in the building, but it's kind of not.
I think people try not to think of crawl spaces.
Yeah, that's it. Yeah, I don't want to think about it. It's the crawl, but whatever's in the crawl is in your house if it's connected to the building. So our approach is seal the dirt and make it part of the building. We treat it like a miniature basement. So if you have exposed earth in your crawl space, or if you currently have a plastic barrier down there, but it's not well sealed to the foundation walls and the seams and around any posts or piers, get a sealed vapor barrier where all those things are completely sealed off.
So in the glacial till of Missoula, water tends to percolate down fairly quickly. In an older house that's been, with its overhangs 2 feet outside of the building envelope, shedding water away from the building, how much water is really percolating through?
I'm not as concerned in Missoula. I'm not as concerned about moisture, although we do see it, because what happens is, especially in the wintertime, we have frozen ground all around our house or building, and so the water vapor is not moving through that soil. So where does it go? To that nice exposed earth in my house. Water vapor just moves up. And so oftentimes under properly sealed vapor barriers, it'll be wet even any time of year. So water vapor does move through it, and people say, well, the dirt in my crawl space is dry. It's like, well, yeah, because all the water vapor's been evaporating into the house. If you dig down a foot, you're going to find that it's wet. Not necessarily really wet, but you'll notice it's damp. But the other issue, aside from the water, is pests, mold, radon.
And air leakage. You would, when we do a blower door test, you would be amazed how much air comes in through the ground. It's astonishing. When they're in the rare case that there is a reasonably well sealed vapor barrier that only has a few holes in it, then all of the air that's moving through the ground is coming through one hole. And some houses, it's like a hurricane coming out from the ground.
Because of all the glacial till.
Because it's very porous ground.
It's porous ground, yeah.
Yeah.
Just today, I was on a job. We just put a furnace and water heater in, seal combustion. We sealed up all their big old combustion air ducts, sealed all those up. They had a really small crawl space. It was only about 15 by 15, and they had a pretty well sealed vapor barrier in it. And they called me and they said, our vapor barrier is like
Lifting up.
what's wrong? You know, I said, well, we just eliminated a large infiltration source of air by capping off all this stuff. So now it's wanting to come in under your vapor barrier.
But it was
And
a sealed combustion, so the fresh air intake should have been coming through that system.
I'm not talking about combustion air for the furnace. I'm talking about just straight air leakage into the house.
So this is an example of a building that has some air leakage going on up into the attic. And they originally wanted us to come and just seal up the attic, but we said, no, we've got to test the whole building. And we found out that when we turned on all the exhaust fans, there were flames coming out the side of their water heater. It wasn't just backdrafting, they were literally, flame rollout is what it's called. But anyway, so the first thing they needed was a new furnace and a water heater, but there's still all that leakage going on into the attic, right? And with the stack effect, so the heated interior of the building creates like a hot air balloon kind of effect. So there's air going out up into the attic, and it's pulling air in down low. So it's creating a suction basically that's pulling air in.
So we sealed off some of their larger, air leakage that was coming into the building by capping off all those old combustion air ducts. Now the path of least resistance was through the ground and pushing up.
But in the process, we also put a heat recovery ventilation system in this building. This comes back to just what I was talking about. Vent it right before you make it too tight.
Yeah.
So we put in sealed combustion appliances and a heat recovery ventilation system. So now they can go ahead and do all the air sealing they want in that building, and they'll still have fresh air, and they won't have carbon monoxide poisoning. But you reminded me of another really common problem that we see in buildings, and that is poor drainage around, especially with finished basements or unfinished basements even. But finished basements is where it gets really nasty. But you'll have ground that slopes towards the foundation walls. You'll have flower beds right up around the walls of the basement, and people are happily watering away all summer long, pouring water down the sides of the building, and those foundation walls are not well waterproofed. Even in brand new buildings, they're never properly waterproofed, and then on the other side of that concrete is very porous to water. Water will just go right through concrete. And on the other side of that is a framed wall full of insulation, and all that moisture is just going straight through. So either ground that slopes, or flower beds, or roof downspouts that come down and just dump a whole lot of water right next to the foundations of the building.
I used to, before I got into this, I was a general contractor, and I had to hammer on the gutter guys. Say, look, I want the downspout. I want a 4-foot extension on the downspout. I want it away from the building, because they'd come, their standard protocol, come down, turn it, elbow, done, dumping it right there. It's like, well, what's the point of the gutters if I'm dumping it all? And now I'm just concentrating it all in one spot.
Right, yeah. So and those are the kind of things that we look at during a comprehensive energy audit. Is to we go around the outside of the building, we look at the slope of the ground, and we look at where the flower beds are, and we look at where the downspouts come down. That has nothing to do with energy performance, but it has a lot to do with the durability of the building and the health and safety of the occupants. Any other questions? Yeah, Bob.
We're doing a bunch of re-insulation,
Mhm.
adding, we don't even think we have insulation in our walls,
Mm-hmm.
because it's such an old house. But that's a huge cost to do the walls, so
Mhm.
we're gonna concentrate on the attics and the basement. But we
Take
look-
this home and read it
I know.
before you do anything. Read that article.
But we're looking at, I've been researching cellulose versus
Mhm.
fiberglass. I want the greenest
Cellulose.
cellulose.
Cellulose, without a doubt. But before you do anything in the attic, you need to make sure that you deal with air leakage from the house into the attic. Because what happens if you just go into an attic and you add more insulation, you make the attic colder. Because now that you've slowed down some of the heat loss, but you haven't. If you haven't gone in and sealed all of the air leaks first, or there's still warm, moist air from inside the building rising up through the insulation, because remember, insulation doesn't stop air movement. It just slows heat flow. So now you've got this moisture coming up, you've made the attic colder, and now that moisture is going to find a cold surface and condense. And we've seen some horribly moldy attics. And it talks about it in that article that if you just go in and insulate an attic without properly dealing with the air leakage from the building, but also making sure it's properly ventilated from the outside. So soffit vents and ridge vents.
Dealing with the bath fan venting,
Making
you'll
sure
likely
bath
find
fans
it
and
vented
drainage
into your
systems,
attic.
Yeah, all of that.
One insulation material that does air seal and insulate is spray foam. And that's what we usually use for the air sealing in an attic. We try to minimize the use of spray foam because it's not that green of a product. It's a petroleum-based
Yeah,
product.
yeah.
But there are, some applications where we need to use it minimally. And an attic is one where we don't have to use very much at all if it's a normal attic like this. We like to maximize the use of cellulose as much as we possibly can. But we deal with so many cut up, messed up buildings that don't really allow us to use cellulose appropriately, and we have to use spray foam. But cellulose is 85% recycled content, and definitely the greenest insulation material that's available for that application.
So I just wanted to point out, this is the website for Montana Energy Services, and if you go to the top right-hand corner and click on videos, we've put together a couple of videos that show, what we consider to be how to properly insulate and air seal an attic. So if you click on that link, takes you to the next page, and there's these couple of videos here, and it shows you what we do. And basically the process, where a lot of insulation contractors would happily just come into that attic and just add more insulation. We start out, we take out all the old insulation. We go around, we cut in this case, this particular attic, there was no soffit vents. And so we had to, we didn't actually put the soffit vents in.
They had that contract with somebody else.
Somebody else
Yep.
came and put in the soffit vents. Then we put baffles. So if this is the roof deck, we put baffles underneath the roof deck that connect to the soffit vents so that the air can actually continue to move through there after the insulation is in. So we make sure the attic's properly ventilated. In this case, there was ductwork up in the attic, and that's a place where you can get tremendous heat loss from the ductwork in the building. So you'll see, and if you watch the videos, we built foam boxes around all of the ductwork and sealed those with spray foam. And then all of the air leaks from the house up into the attic, so the tops of walls, all the top plates of walls, every light fixture, every bathroom fan, every place that there was a hole between the house and the attic, we sealed every one of those with spray foam. And then we built a catwalk. So we went up about 2 feet off the ceiling. Yeah, so Russ is sitting on it right here. So we came up about 2 feet and built a wooden walkway through there. Because every attic we go into when we do energy audits, every existing attic we go into, even the rare ones that are actually have a nice layer of insulation, it's all been messed up by people walking through it. Or in a lot of cases, contractors come in and say they put in a new light fixture, and they'll shove all the insulation out of the way, put in the light fixture and leave. We see it all the time, and we look with the infrared camera and like there's this big blue patch on the ceiling. We're like, yep, somebody's been up there. So we build this catwalk so that you can actually get through the attic in the future without messing up the insulation that we're going to all this trouble to put in. We build a dam around the access hatch, the full depth or deeper than the insulation that we're going to put in, and we actually insulate the hatch itself, which you never see on existing buildings, and then we put a gasket around it so it actually seals, and we do all of that before we even think about putting insulation in an attic.
Would you take out the old fiberglass?
Every time.
Why?
Because you can't get to the air leaks without taking out the old insulation.
I mean, you could technically push it all to one side and seal one side and then push it all to the other, but for us being hired, it's faster and less expensive for us to do it. We, a lot of time, we're doing a big one right now, and we often, Home Resource will take it. So
The
that-
old insulation, right?
yeah, like we have a big vacuum where we suck the insulation. If it's loose fill insulation, we'll suck it out into these big bags and we donate them to Home Resource. So as much as possible.
I'm curious, if you're getting into attics a lot, how often are you encountering zonolite?
You
Zonolite.
mean vermiculite?
Vermiculite.
Oh.
Brand name zonolite.
Right.
You know, we haven't seen very much of it. There's one there though that we did. But if we do encounter it, we're not a certified asbestos remediation contractor, so the homeowner has to get it. If we suspect it, the homeowner needs to contact someone to test it, and then if it does have asbestos in it, it needs to be removed by someone who's licensed for it.
And so when we're doing an energy audit, before we run the blower door test, we do an attic inspection, and we inspect everything. And if we see anything that looks like it might have asbestos in it, we won't do what's called a depressurization test, where we blow air out of the house, because that could suck that asbestos into the house from the attic. So in Pat's case, I had to do what's called a pressurization test, where we turn the fan around and blow air into the house, so that we weren't just potentially sucking asbestos into his house.
I just wondered, like, pre-1980 homes, in your experience, how common do you encounter that?
Not terribly.
Yeah, I mean,
I've only seen it in the one house.
Yeah,
Yeah.
in the 5 years I've been doing this, I've only seen it in one house, one or two. Seems like most of them have been remediated, the ones that have had it. That actually brings up a good idea for me to contact the asbestos contractors. To talk to them and say, hey, when you're sucking them out, now is the opportunity. So just to educate them about air sealing before they blow new insulation in.
Right, yeah. Have them watch these videos.
Yeah.
Yeah.
Are there flammability issues with cellulose?
No.
It's treated with borax.
Borate.
Right,
Borate.
acid?
Yeah, borate.
But doesn't that leach out over a period of time?
Only if it's getting soaking wet.
Or really? Not just atmospheric?
It won't leach out in the air, no.
Okay.
Yeah. Hopefully it's not getting soaking wet.
Yes.
When you're doing a dense pack cellulose wall, compare that to a dense pack fiberglass wall. Is the insulation value comparable, or is it different?
The insulation materials themselves have slightly different R values per inch.
It's close. It's actually
Fiberglass is a little bit higher.
It's slightly higher for fiberglass in
Yeah.
a dense pack wall. Yeah.
The key with the dense pack is making sure that you're getting the appropriate density
Right.
to achieve the R value that you're going for.
And what we see in attics is there's a huge difference between fiberglass and cellulose, because it's not dense packed. The fiberglass is so fluffy that when you look with the infrared camera, you see just tons of heat, just not air leakage, but just heat rising up through fiberglass insulation, and much less with cellulose.
Because it's so permeable.
Because the cellulose is heavier material, and it just packs itself tight. When you first put it in like this, where he's just blowing it, it's really fluffy. It's weird. It's like Jello.
Yeah.
You can like wiggle it, and it'll wiggle like 6 feet. It'll wiggle.
You have to be
Yeah.
really careful though blowing it, because if you blow it too far away, then it gets a bunch of air and it's going to settle a whole bunch. So you have to really be careful with how adjusting how much air is going through the hose with the material, and blowing the proper amount. So.
I think we'll stop it there. If you have any other questions, you can come ask Russ and Andy later.
Well, and you're welcome to contact us if you want to take one of these. Both of our websites are on there, which has you can contact us through either website, or the websites also have our phone numbers. I didn't put the phone number on here. I was in a rush, but you can get all our contact information off the website.
Great. And I want to thank you all for joining us. Don't forget to thank our sponsors if you get a chance. Our next Sustainability Shop will be January 13th. We will have Sue LaRue from First Interstate Bank talk about sustainable banking. Can it be? And we hope you'll join us. It'll be here at the Loft again. We hope you join us for that event. And we hope you guys have a good night. Thanks.
Thanks.
you.
Thank you.